Welcome to Summarize Science, where we simplify the most complex research for everyone. Today, we are diving into a paper that aims to give robots a better way to see in the dark using thermal energy. Standard 3D mapping usually relies on RGB cameras, which are essentially the same as the ones in your smartphone. However, these cameras become useless when there is smoke, heavy fog, or no light at all. To overcome this, researchers at the Technical University of Munich are using thermal infrared sensors instead. Thermal cameras detect heat signatures rather than light, allowing them to see through visual obstacles. The researchers developed a new method called Thermal-to-Depth Gaussian Splatting, abbreviated as TDG. This system is unique because it doesn't need to be paired with regular photos to understand a 3D space. This makes the entire process faster and more efficient for the computer to handle. By focusing on a single type of data, they avoid the multimodal mess that usually slows these systems down. The technology uses something called Gaussian splatting, which turns a scene into thousands of tiny 3D blobs. These blobs are then optimized to match the heat patterns seen by the thermal camera as shown in this architecture diagram. One of the biggest challenges was teaching the AI to understand depth without regular visual cues. The researchers solved this by integrating a thermal-guided depth estimation module. This allows the AI to estimate how far away an object is based solely on its thermal appearance. They even used a progressive training strategy that starts with the general layout and slowly adds fine details. When comparing their TG method to existing baselines, the improvements were significant. In many cases, it outperformed the previous gold standard for thermal mapping quality. The most impressive statistic is that it reduced training time by over 12 minutes, which is a 55% improvement. This speed is crucial for real-time applications like emergency response. You can see the visual results here, showing how well the AI reconstructs complex objects like glass cups and indoor scenes. Even in low-light environments, the thermal signatures remain crisp and accurate. This is a massive win for industrial inspections where machines need to be monitored for overheating. It could also be used to create digital twins of buildings to track energy efficiency and heat leaks. There are still hurdles to clear, such as handling very large buildings or areas that are hard to see from certain angles. The researchers noted that they currently still use some initial data from regular photos to set the stage. Future work will focus on making the system entirely independent of any visible light data. To recap, this paper shows the researchers can build accurate 3D maps using only heat sensors and clever AI. This means faster, more reliable vision for robots in the most dangerous environments on Earth. Imagine a future where rescue drones navigate fire-filled buildings with perfect 3D awareness. That is the power of thermal Gaussian splatting, and it's a big step forward for robotics. Thanks for watching Summarize Science, and stay curious about the technology of tomorrow.